Hello, YouTube. This is Emails03. For several lessons now, we've been talking about some more advanced data structures, right? For a long time, we've been familiar with lists. We've been using lists for most of the 55, 56 lessons that I've recorded. And then we talked about tuples, and we said tuples are sort of like lists. They have index positions, but they're not mutable, right? You couldn't add or remove or modify elements from a tuple. And then we talked about sets, and we said sets can only have unique elements, right? They're unlike tuples in a couple ways. First, they're not referenced by index position like lists and tuples are, but sets are also different from tuples because with sets you can also add or remove elements, right? But only uniquely. So if an element already exists in a set and you tried adding that element again, there would be no effect. It would be like if you were trying to remove an element that was not there already. But anyway, we also have dictionaries, which are basically key value pairs. And so we're going to be reviewing dictionaries in this video. And then also reviewing or talking about 4 more data structures. So we're already familiar with strings. And then in the last 2 videos, we talked about stacks and queues. And then in this video, we're also going to be talking about a frozen set, which is like a set that you cannot add or remove elements from. So it's sort of a little bit more like a tuple in that you can't add or remove elements from it. It's a set that's not mutable. So let's think about what these 8 data structures have in common. We're going to talk about frozen sets later, but we already know that these first 7 data structures, what can they all do? Well, they can all have mixed data types, right? A set could have floats and booleans and strings in it all at the same time. Same thing with a list. Same thing with a stack or a queue, right? We talked in previous videos, we basically came up in the previous 2 videos with 2 classes, right? We made a queue class and a stack class to basically be object-oriented representations of stacks and queues. And we said that we could have varied data types. You could have booleans and ints in a stack or queue. So hopefully that makes sense to you. And then you can also determine whether an element exists within an iterable, right? We could see whether an element exists within a set or a list, or we could see whether a key exists within a dictionary, and you would just use the word in. And so this shows you a couple of examples, right? Like we could have a walrus operator where we say print of my list : equals, and then basically a list with a lot of varied data types. So hopefully that's clear to you. And we could do the same thing with tuples and sets and dictionaries. Okay, but then what we want to do is we want to talk about list functionality in particular. And we know that there's a boatload of things we can do with lists, right? We can retrieve an element by index position. We can concatenate a list with another list. We can add elements to the end of a list. We can add elements somewhere into the list. We can modify the values at index positions. So L of X equals Y, what would that do? That would modify the element at index position X and basically reassign it to the element Y. Okay, you can get the index position of the first occurrence of an element in the list. You can count the number of times an element occurs in the list, right? So that would return 0 if the element doesn't appear at all. You can remove the first occurrence of an element. You can remove an element at a particular index position. So one of the things we might not have talked too much about is if you say dot pop on a list, that would remove the element at a particular index position, right? You can also clear all elements from a list. You can reverse the elements in a list like L dot reverse. And then we also said that you can convert a list to a tuple or set, right? Tuple of L or set of L for some list L. And then we also talked in the previous 2 videos how we could create a stack or a queue. And basically what happens in the constructor for those 2 classes is we create an empty list, right? And so every time we push an element onto the stack or queue, that element will be added onto the list. So we can do a quick example here, but if you have basically a set, I created some functions down here and we want to basically think about a list. So we could do define try list, right? And so here on line 199, you see basically a list with varied data types in it, right? So 66 is an int, but 32 is a tuple, right? And then happy is a string. Not true is a boolean, right? And then we can concatenate another list onto the first list to get my list, right? And then you could say for S in enumerate of my list. Remember we talked about how enumerate is a generator that basically returns tuples, where the first element in each tuple is the index position. The second element in each tuple is the element that was at that index position. So anyway, let's go ahead and try running this. I don't want to waste too much time here, but we can do try list, right? So we can go ahead and just try this try list function. And I want to show you the output here. So we went ahead and said, let's see, there's a lot of functions here. So we could say for S in enumerate of my list, print of S, and then print my list dot index of 66, right? So as the result of saying for S in enumerate of my list, we get those tuple pairs, right? Index position element, index position element. It's a generator that we talked about in lesson 24. And then we also have my list.index of 66, right? So that would give you 0 because 66 occurs for the first time at index position 0. And then my list.pop of 0. So that would allow you to remove the element at index position 0. So then if you tried a try except block where you tried printing the index position of the element 66, well, after you remove it, it would basically say 66 is not in this list, right? It would raise a value error. And so instead of raising that value error, we would say 66 is not in this list. And then the length is not greater than 0 since we cleared the list. So that would be down here, right? So if we clear the list, that's something we can also do, is remove all elements from the list. And then we would basically be able to assert that the length of the list is greater than 0, but this is a false Boolean, so it would create an assertion error. So hopefully that makes sense to you. And then we can also talk about tuples. So with tuples, we have a little less to talk about, right? There's a whole lot less you can do with tuples, but you could retrieve an element by index position, like t of x for some tuple t in index position x. You can get the index position of the first occurrence of a particular element. You can count the number of occurrences of a particular element in the tuple, right? And the tuple we're talking about now, tuples. You can convert it to a list, you can convert it to a set, and you can convert it to a frozen set. That's what we're going to be talking about in this video. But anyway, let's go ahead. I'm just going to have another function here, so I'm trying to go quickly if you can't already tell. But we could do a try tuple, right? So let's think about what would happen here. So we're going to run the try tuple function. You can see that there's a couple things that appear on the screen. So let's try to make sense of what we have going on here. So we have my tuple, and we basically create a tuple by concatenating two tuples together. So we said, like with lists, we can also concatenate two tuples, right? And then we also talked in lesson 45 or 46 about tuple unpacking. And we said that we could basically have comma separated variables that are assigned to a tuple, right? And then you could go ahead and print those values. So what if you say print val1 plus val4? Well, that would basically go ahead and print 5.2 plus 3 because we concatenated those two little tuples to form the overall tuples. That would be like the first element plus the fourth element. And then you could do the integer division, the floor division of the third element and the fourth element. So how many perfect groups of 3 are in the number 14? Well, 4. So that's why we get that on the console. And then what if you do print of my tuple.index of int of true times 3? Well, remember, for any Boolean that's true, int of that Boolean would be 1. So 1 times 3 is 3. And if you want the index position of the first occurrence of the element 3, that occurs at index position 3. So hopefully that makes sense to you. And then my tuple.count of 877 returns 0 because there are 0 877s in the tuple. How about with a set? So let's think about with sets here. So essentially what we have going on with sets is we can say that we can add elements to a set. So s.add of x, for example, we can clear all elements from a set. We can remove an element from a set, but only if the element was already there, right? So with sets, we're talking about only having unique elements. So if an element already exists in the set, then calling remove would not have an effect. We also talked a little bit about intersection and union. So if you have two sets like S and V, and you say s.intersection of V or s.union of V, that would return a set either with all unique elements that exist in both L and V, if you call intersection, or at least in one of the two sets if you call union, right? So it's kind of like and or. So we can see examples of that. We also have subset and superset, right? So if you say for two sets S and V, if you say S dot is subset of V, that would return true if all elements of S exist in V, right? And then if all elements of V exist in S, then S dot is superset of V would return true, right? The superset would basically, it's like the opposite of the subset. It's like if all elements in my first set, are, basically envelop or contain all the elements in the second set, that would be like a superset. And you can also convert a set to a list, okay, or to a tuple. And so that would give you index positions, right? If you want it to be mutable, convert it to a list. If you want it to be immutable, convert it to a tuple, right? And then we'll also talk about this frozen set in a few minutes. So then if we go ahead and we want to go ahead and see some examples of a set, right? So if we say try set, and then we can look at these two sets, right? What if we did the union of the set 1, 3, 5, 7, 9 with the set 2, 4, 6, 7, 9? Well, that would give us all elements that are in at least one of those two sets. So anyway, what we can do here, I just created some methods down here on the bottom, but we could go ahead and say try set. So now if we go ahead and run it, we could go ahead and get a sense of what would happen here. So with the try set, we would basically see 1, 2, 3, 4, 5, 6, 7, 9 for the union. But for the intersection, how many elements are in both of the two sets? Well, that would just be 7 and 9, right? And it's unordered. So 7, 9, 9, 7, same thing, but only 7 and 9 appear in both of those sets. What if you create two sets, set one and set two, and you want to know the length of set one? Well, that just gives 3, right? Because there's only 3 unique elements in set one. What if you want to see if true is in set two? Well, that would be false, because here you can see that there's no true Boolean in set two. There's only the string true. Okay, so hopefully that makes sense to you. And then you could do an is subset or an is superset. So we would say that set one is a subset of set two, because 5, 7, and 9 all appear in set two. But set one is not a superset of set two, because 115 is not in set one, right? Not all unique elements in set two appear in set one. So hopefully that makes sense to you. And then if we say set one dot add of 52, right, we can add elements to a set. And then we could say for t in list of set one, print of t, right? So that would just give us the unique elements in set one. So 9, 52, 5, and 7. We can also think about a dictionary. So we said basically if we go ahead and scroll up here, so with a dictionary, we can retrieve a value by key. So we could say d of k, right? We can have sort of index positions, but not really by non-negative integers. Here they're by keys. And the keys could be anything, right? Keys are a little bit more general than just index positions, but you would retrieve a value by key, either saying d of k or d.get of k, where d is the dictionary and k is the key. You could say also d.get of k comma v, right? That would return d of k if k already had a value, right? But it would update d of k to v if there was already not that key, if there was not already that key value pair there, right? And you could say d of k equals v, d dot update of kv. These are just a couple of ways that we talked about for adding a key value pair to the dictionary, or replacing the value, that is already assigned to a key. And then we talked about a couple about generators, right? So we said d.keys or d.values, those don't return anything. Those aren't lists or tuples, but they're generators that can yield the keys or values in the dictionary. And then we could also do d.pop of k. So that would remove the value v that's currently assigned to one of the keys k. And if you say d.clear, that would remove all key value pairs from the dictionary. You can also convert a dictionary to a list, a tuple, a set, or a frozen set. And basically we would be talking about the keys, right? So if you have a set of keys in a dictionary, you could convert that set of keys to a list, a tuple, or a set, or to a frozen set, as we'll discuss soon. But basically you could have a tri-dictionary. And so we have my dictionary, and we have a few key value pairs here, right? Monday gets assigned to 88. Tuesday also gets assigned to 88, right? We said the keys in a dictionary have to be unique, but not the values, right? And then we could say print of Wednesday in my dictionary. So that would be true because Wednesday is a key in this dictionary. But if you say print of 88 in my dictionary, that would return false because 88 is not a key. But we can go ahead and try this out. So if we say print, if we say try dictionary, hopefully we can get a sense of what's going on here, right? So we could say, if we scroll up here, we could say, where's the dictionary? So this would be 88 in my dictionary. That would return false here, right? Because 88 is not a key. But you could say print of 88 in my dictionary dot values. And since 88 is a value, then that would be returned as true. The length of my dictionary, 3. There are 3 key value pairs. If you just wanted the set of keys, you could do set of my dictionary, right? You could update the key assigned to the, you could update the value assigned to the key Monday by saying my dictionary of Monday plus 2, right? If you say my dictionary of Monday equals my dictionary of Monday plus 2, that would be one way to assign or replace a key, right? And so that would just update the value associated with Monday. Instead of being 88, it would now be 90, right? And then you could also update the value associated with Thursday to be false, right? But here, it doesn't look like the key Thursday has a value associated to it. So this would just add the key value pair to the dictionary. And then if you say my dictionary of Thursday is 85, well, now the value associated with Thursday is not going to be false anymore. It's going to be 85. So then if you go ahead and say print my dictionary dot get of Thursday, that would return the 85 here. And then what if you say my dictionary dot pop of Tuesday and my dictionary dot pop of Wednesday? Well, that would remove the key value pairs for those 2 keys. And then what you could do, there's other things you can do here. So we'll just go a little bit longer. First tuple equals 2 comma 4, right? We said we could create a tuple either with or without parentheses, but the values would be comma separated. So first tuple equals 2 comma 4. Second tuple equals, parentheses 3 comma 5. Third tuple equals tuple of my dictionary. So that would be a tuple representation of the keys that were in the dictionary. So then if you say for X in first tuple plus second tuple plus third tuple, right? It's a concatenation of several tuples together. We're just going to want to print the values. And so that's why we would print 2, 4, 3, 5, Monday, Thursday, right? Because those are the values that are being concatenated into this tuple after we popped two key value pairs out of the dictionary. We also talked in lesson 23 about string methods, right? So we also talked a little bit about strings, and I think we're running out of time in this video to talk about frozen sets, so that'll have to be part of the next video. But basically what we can do with strings, right? We talked about multiple things you can do with strings. You can retrieve a substring by index position, right? What if you said W of X, right? Or W is some string and X is like the number 2 or the number 5. That would return the character, you know, there in the string. And then concatenate one string with another string, right? So if you say summer plus time, that would be concatenating those two strings together to get summertime. And you can also get the index position of the first occurrence of an element, W dot index of Y. This would be like the first occurrence of a character, to be a little more specific. You can count the number of occurrences in the list, the number of occurrences of a character in the string, right? To be a little bit more specific, the number of occurrences of a character in the string. Hopefully that makes sense to you. And then you can convert it to a list, so list of W. Basically, we didn't talk too much about that, but you can actually convert a string to a list, okay? And so basically the elements in the list would just be the characters, right? If you have butterfly, then you would have a list where it's like one element is B, the next element is U, the next element is T, the fourth element is another T. So hopefully that makes sense to you. You can also convert a string to a tuple or a set, so we'll see a couple of examples of that. And then you can also do, remember with strings, remember you can also do int of W, right? So like int of W, if you say int of and then the string 32, that would give you the number 32, right? So int of 32 minus int of, 2 concatenated with 7, well, that would really be 32 minus 27, so that's 5, right? But then you could also do float of a string and bool of a string, right? We know that the bool of any string other than the empty string would be true, but the bool of the empty string is false, right? So then we can go ahead and try that out real quick and then, spend the last 60 seconds reviewing stacks and queues, right? So we could go ahead and say try string, and unfortunately we'll need to have one more video to talk about frozen sets in the next video. But what if we say try string? So let's think about the output associated with that function. So if we say word 1 equals butter, right, with a capital B, and then word 2 equals fly with a capital F, and it looks like there are also periods in between the letters. And so what if you say print of word 1 dot lower plus word 2 dot lower? Well, remember we talked in lesson 23 about how there's some string functions, some string methods. And so that would basically give you butter, all lowercase and then concatenated with f dot l dot y, but now the f is going to be lowercase. And then what if you say print of word 1 dot count of capital T? Well, that would give you 0, right? There's no capital T's in this butter word, right? But if you say word 2 dot index of dot, that would give you 1, because the first time that the dot occurs in f dot l dot y is at index position 1. If you say print of word 1 of 0, that would give you basically the capital B. It's the first character in butter. Print tuple of word 2, so we said we could form a tuple out of a string, so that would just give you a tuple where all the elements are like the characters in the string, right? And then we could also say, remember the replace and the ends with and the starts with, right? So print of word 1 dot replace of T comma F, that would return another string where every occurrence of lowercase t is replaced with lowercase f. So that would give you buffer instead of butter. And then we could also see if word 2 ends with the lowercase y, so that would be a true. But then if we ask if word 1 starts with lowercase butt, that would be false, because this is case sensitive and we're starting with a capital B, right? And then if we say print string to list colon equals word 2 dot split of dot. So remember, if we take a string and then we call dot split of some separator, it returns a list, right? Where basically the elements in the list are going to be separated by whatever the separator is that you indicated, right? So we could say a list with F, L, and Y, because that would be a list where all the strings, where all the elements are separated by this dot that we saw in the original string. And then there's also a join function, which you can go ahead and review on your own. And then we also talked about stacks and queues, right? So we said stacks is like a last in, first out data structure, right? And you could implement it by creating a stack class like we did in lesson 54. And it would start out as an empty list, and you would basically go ahead and have to have a push and pop functionality. Remember that elements that are added last into the stack will be the first out, right? And then with a queue, it's the opposite. So this will be a first in, first out data structure. And we talked in the previous video about how to implement that using a list. So we'll talk more about advanced data structures in the next video. I want to talk about another type called a frozen set, but I think that's enough for now. From UMOS03, thanks for watching, and please subscribe.